Here's a lesser known fact about me. Once upon a time, when it was just me and the dinosaurs, okay, maybe not that far back, but long before VR headsets, the metaverse, and the social media craze, I used to teach people things for 8 years. I loved it so much that honestly I could talk for hours. Don't worry, I won't in this video, I promise. Anyways, enough of my rambling. Recently, I rediscovered that passion for teaching, and I'm thrilled to kick off a VR tutorial series in Unreal Engine. That's why, as the introductory step into this series, we're diving hands first into the fascinating world of virtual reality. But before we jump in, make sure to hit that subscribe button so you don't miss any of my VR adventures. Ready? Let's bring those virtual hands to life. So let's first see what the aim of this tutorial is. The aim is to basically be able to create a VR application that is able to track the hand data and also able to basically animate a virtual hand or a set of virtual hands. And as you can see, I'm using cubes for this purpose in this tutorial, and also be able to detect a pinch. Like as you can see here, it's a gesture that I could basically with any of my hands produce. For example, you see for the other fingers or any other kind of gesture, I don't recognize them or do anything. But here, the only gesture basically we are going to detect in this tutorial is like a pinch. As you can see, it just works really perfect. And when I do detect a pinch, I'm gonna basically create a particle. And using that, I could basically paint inside the environment. That's the aim of this tutorial. We are going to do it in Unreal Engine 5.4, and then we are going to upgrade it to Unreal Engine 5.5 because there are some changes. Also, the code you are going to write in Unreal Engine 5.4 is going to work in 5.5, but for the next release, since Epic has deprecated the previous API, probably they are going to remove it. That's why we are going to do some adjustments in order to be compatible with the newer versions of the engine. But let's put aside the headset for now and just go back inside Unreal Engine. Apologies for the interruption. For some esoteric reason, my video feed gets frozen whenever I stop the VR preview inside Unreal Editor. I've tried various recording software. Unfortunately, none of them help. And that's something we are going to do a lot, basically hop into the VR preview and stop it whenever we are developing our game or simulation. But yeah, I could basically continue without that. But before we start the actual tutorial, there are some requirements that you need. I'm going to quickly mention them. The first thing that you need in order to be able to install Unreal Engine is the Epic Games Launcher. And for downloading Epic Games Launcher, you could go to this link on the official website. And once you download it, you need to also create an account. You need an Epic account. And if you follow this tutorial, it just explains everything, how to create an account and how to install any versions of Unreal Engine that you desire. But for the sake of this tutorial, we are going to use Unreal Engine 5.4, and then we will upgrade it to Unreal Engine 5.5. As I've mentioned, there are some API changes, but any recent versions of the engine are going to basically behave like Unreal Engine 5.4. And once you have any of those, basically you could try this tutorial. In addition to that, also you need a VR headset, which I'm going to use MetaQuest 3. MetaQuest 2 works the same way. Also, you could use Vive headsets like Vive XR Elite or Vive Focus 3. But for those, you need different software like SteamVR and their own Vive Business Streaming and things like that. Here, I'm going to download MetaQuest Link, which is an app that is going to stream from PC the VR content to your headset. And by the way, you could develop in a standalone mode, which is basically you are going to deploy to the headset itself and run the application without the need for a PC. It's just like developing any other Android application because the operating system on Quests are Android. But since setting up that is a bit more difficult for most people, I'm going to stick to the PC VR. That's why I'm using MetaQuest Link. This application you can see, and it recognizes my Quest 3. But for that also, you could go to the official website. Here is the download link and the installation instruction. And for this, you also need a Meta account, either a Facebook account, or if you were previously an Oculus developer, you could use that account as well. Once you install MetaQuest Link on your PC, you have to go to your headset and from the launcher, run this Quest Link. And as you can see, either using AirLink or a cable, you could basically connect to the system. And then hit the launch button. It's going to run this, and you have to keep this open. And once you do everything correctly, sometimes you have to restart the engine, but in the recent versions, it's usually not necessary. You have this VR preview. Otherwise, it will be grayed out. So that's also something else you need. And I think we got everything out of the way in terms of requirements. Then I am going to close the engine with the sample project I have, and I'm going to Epic Launcher, launch the Unreal Engine 5.4. And once that is it's running on my second monitor, but it's going to show us a screen that we have to create a new project and choose the application type, which I'm going to create a virtual reality application. It's again open on my second monitor. That's why I'm dragging it here. Once this wizard is open, it's called Unreal Project Browser. You go to the games and you choose virtual reality. I don't need a starter content, but I could leave it as well. But this is the path you are going to put your project in, and I'm going to call this VR hands. And then once that is done, I'm gonna hit the create button. As I've mentioned, we are going to use PCVR, which means we are going to stream from the PC using this Quest application. And something I forgot to mention, which probably is not the default, and you have to basically take care of that, because otherwise what I'm going to tell you in this tutorial is not going to work. The thing is, you have to first on your headset, go inside your headset and in the settings section, enable body and hand tracking. That is a requirement for this one. Otherwise, your headset is not going to track the body and hand movements. In addition to that, one important thing is for the VR preview to work, this one is you have to go to the General tab and set the OpenXR runtime as MetaQuest link. If you don't do that, Unreal is not going to basically stream from your PC to the headset using the MetaQuest link. Also, one more important thing for the hand tracking to work on the PC side, you have to go to the beta tab, and this is very important. I said you should have a Meta account. Basically, if you have a Meta account, it's not going to just work. It should be a Meta developer account. You could look at the documentation how to become Meta developer account. And once you're a Meta developer account, this option is going to appear here. It's called developer runtime features, and this should be enabled. And as I've mentioned, it is only visible to the developer account. If this is not enabled, again, the hand tracking is not going to work. I'm going to reset my engine layout, but the thing is here, it just moved to the other screen. I want to keep this docked, the content browser. Okay, sometimes Unreal, when you start a new project, the layout, it does not look like the default layout, so that's why you have to reset it. Anyways, for the remainder of this tutorial, I'm going to create a folder and put everything here. I'm gonna call this, for example, Mamadou VR. Inside here, I'm going to create a blueprint project. This VR template is something that is shipped with Unreal Engine themselves. And then basically it just got everything set up for you, and you don't have to do anything. You just hit the VR preview button and everything works. But normal Unreal projects, you have to do some stuff on it in order to make it VR compatible. But we don't care about that right now. I'm going to just basically hit the right click. I'm going to create a blueprint class of type actor. I'm going to call it BP VR hands. And for this to work, this is really important. You have to drag an instance of this inside your scene. Otherwise, it's not going to work. Basically, at the beginning, when we run our game, it's just going to spawn one of these inside the scene that is going to execute whatever code we are going to write. We can test that if, for example, I press Ctrl Z. As you can see, it was removed from the scene. I go inside this blueprint, and I don't like this because I want basically everything to be opened as tab, and I don't know why every new project I create, Unreal keeps resetting these settings. Basically, if you go to the editor preferences, appearance, and here come to the editor asset open location, I'm going to make it main window. And then if I go and reopen this, it should happen, but probably it just remembered it. So yeah, now as you can see, it just opens in a new tab, full screen, which I like. Anyway, here there's a event begin play. I'm going to basically create a node here inside the blueprint editor. It's called print a string, and it's just going to print hello. I'm going to run the game. I don't care about VR preview at the moment, just I want to run the game. As you can see, nothing appears here, but whenever I drop an instance of this inside the scene and press the play button, the hello appears here, which means now it can execute my code. So it is important to basically drop one of the instances of the blueprint that we write inside the scene in order for our code to execute. I'm going to reopen this and delete this. Hit the compile button. If there's any error, it's going to always show you, because like any programming language, blueprints also needs compiling. So you can validate if your code is valid or not, and then make the adjustment in order to make it execute. But the first thing, as I've mentioned, is we are going to get the hand tracking data. And once we got the hand tracking data, we want to draw some joints. In Unreal Engine and in OpenXR, when you get the hand tracking data, there are 26 joints. I'm going to show it to you here. If you look up OpenXR bone names, basically you will find this picture on Google or similar ones. As you can see, if you count these, there are like 26 joints here from the wrist all the way to the tip of the finger. And each of these joints have a name we will see later. But we have to first extract this data from the engine. In Unreal Engine 5.4 and the previous versions, you could use get motion controller data. It's a bit confusing because motion controller is a different thing than hand tracking. That's why they decided to change this function and change the data format in Unreal Engine 5.5 because it was a bit confusing. But anyway, we are going to use the get motion controller data in the older engine version. By the way, this is going to work on 5.5 as well. But as I said, they are deprecating this, and probably in future Unreal Engine versions, this is not going to work. But for the time being, we use the get motion controller data. And once you basically call this function, you have to specify a hand like the left or the right. And once you do that, it's going to return the motion controller data. I could right click on this, split the struct. As you can see, it's just going to show me what data are here. Don't worry. I know there's a lot of stuff there, but we don't need all of this. And I'm going to explain the important ones. But also you could use the break node, basically. You could use this to just break the struct to its parts and use the data separately. So what am I going to do, because I don't want to basically clutter here. I want to create a function called get joint transforms. What is a transform? A transform is basically in Unreal Engine is a collection of a vector, which is used for tracking the location, quaternion rotation, or Euler angle. This could be used interchangeably. You could basically convert between them. If we want to know what are quaternions, you could go basically read the Wikipedia page, or also the Euler angles. The rotation is in Unreal Engine basically could be represented as any of these. And also a scale, which is the size of the basically those joints or object. So I'm going to basically extract the motion controller data for either left or hand right, and only return a transform from that function, an array of transforms actually, because as I said, we have 26 joints. I want to return an array containing all the data and then use that to draw a hand or do the gesture recognition. So here I'm going to add a function inside here. Once you're inside your newly created blueprint, I'm going to call this get joint transforms. And inside this, like any, if you have ever like programmed in any programming language, you have some function parameters. It goes into input and also return values, which could go to output. So for the input, I need to know which hand I am going to basically process the data for, or get the data for. Then here I'm gonna type e controller hand, which is a enum, controls the hand, which hand is it, left or right. And also in the output section, I'm going to return an array of transforms. So here I'm gonna add, call it joint. I'm going to call it just transforms, and just use transform, and we are going to make it an array using this button here. Otherwise it will be a single transform, which we don't want. Basically what we get as input is a hand, what we return is an array of transforms. But anyway, let's for now get rid of this. We don't care about this. Put it somewhere. But at the beginning, I'm going to basically call the get motion controller data. And once I do that, I have to, of course, connect the nodes. That means whenever I enter the function, the get motion controller data is going to be processed. And I'm going to connect the hand as the function parameter. It just comes in and pass it as an argument to this get motion controller data. As you can see here, I could specify left or right, and also these are like other motion sources that you could use inside Unreal Engine. Don't worry about them. You only need left and right for the hand. And then I'm going to connect this. I don't care about the context because the current basically BP VR hands is going to be passed as the world context. But for now, just get motion controller data is going to return the data. Then I'm going to break the structs. I want to see what is in here. Again, let's get this out of the way. And here, what am I going to do? Let's just first quickly see what is here. The first thing that you want to basically check is that your struct, the data that were returned to you, is valid, because sometimes the hand tracking gets deactivated. For example, when you touch a controller, press a button on the controller, the hand tracking on quests are usually getting disabled. So that's why any data you receive from this function is invalid. That's the first thing that you should check. So I'm going to put a branch here. Branch is like if in any other programming language. I say, so here also we could add comments. I'm going to select these, press C. I'm going to say get the actual hand tracking data. So this section of the code, as you can see, is just going to get the hand tracking data. I'm going to make it black because I believe it's not really readable. Now maybe it's better. So this portion of the code basically gets all the data we need from the engine for hand tracking. That's it. That's all you need to do. All the underlying stuff is done by Unreal Engine. And also I've written basically hand tracking plugin for processing the data. You don't have to do that. Unreal provides you with just one function call. You could just call the get motion controller data and have the data, and that's it. That's all you need. But anyway, I'm going to connect this to the if. So the next thing after getting the data is the data validation. I'm going to say if it's valid, then we are going to continue to do something else. We do our own validation as well, because we want to also make sure the data we received is actually from a hand, not a motion controller. So for that, there's something here called device visual type. You are going to, sometimes it's just the engine freezes, which is weird. So I'm gonna drag another node. Here I'm gonna type switch, which is like switch in C, C++ or any other programming language that have a similar concept like C# or Java probably. You are switch on this enum. And here it's just going to be either a controller or a hand. So I say if the data is valid, then the next step is to check if it's a hand, the visual type of the motion controller data we are going to get. If it's a controller, I have to return. If you don't return from the function, basically we are going to return early. We are not going to run the rest of the function. You are going to experience weird bugs because this function, when we were compiling, basically defining the function, here we define the return type. If we don't do that, it's just gonna basically create weird bugs. So if it's a controller, I'm going to return an empty transform. That's it. You don't do anything else. But if it's true, then I will proceed to the next step. Of course, I could check the tracking status here to see if the device is being tracked or not tracked. With Unreal Engine's hand tracking, honestly, I find this a bit buggy. Sometimes it's reports that not being tracked while the data is valid and it is tracked. I don't know why. Maybe I get something about this wrong, but anyway, I'm not going to use this because just we confirmed if it's a hand that is enough for me, and if the data is there, I'm going to check the length of the data I need, like the 26 joins I talked about here. If we have 26 joins, then I'm going to proceed and do something with the data. So here, as you can see, we have hand key positions, which is the location, the vectors in the 3D space, and it's in world basically location, because in Unreal Engine you could have world space, local space. World means that is relative to the origin of the world, which you have inside your scene. For example, if you put an object here like the floor, it's on this location, but you also could make it, for example, 0, 0, 0, which means this is the origin of the world on a basically 3D coordinate system. Yeah, I'm going to Control Z this because I don't want to just when I spawn, I will fall off through the ground, which I don't want. But anyway, the thing is that location is relative. Basically, it's in absolute position relative to the origin of the world, but you could also have other coordinates like local space or component space. We don't care about this. It's easy here. It's just in world space. We don't do any conversions for that. Also, we have the rotations, and as you can see, it's just going to return a quaternion, but quaternions can be easily converted in Unreal Engine to Euler angles. It doesn't matter which one we are going to work with. We don't even know, don't have to know the math, how to do it. These are something that is provided by Unreal Engine, and this radi is basically, it's just going to be a scale of the joints that you have. But anyways, let's get to basically the validation of the rest of the data. So the other two things that we need are these. For a scale, we are going to use our own scales because we want to spawn cubes at the same size. So here in the hand key positions, I'm gonna basically drag a node, say length. I'm going to check the length of the array also for this one, length. So here I'm going to say if it equals 26. So this way I'm going to basically make sure we have like 26 joints for each of these. If they are not 26 joints, then we're going to fail. But here also I'm going to do a Boolean AND, like many programming languages. If both of these are equal to 26, then I'm going to have another branch, which means here. Okay, let's actually comment this code also, because if it's also a hand, then I will do the rest of the checks. So I'm gonna select these. I'm gonna call this data perform data validation. Let's make it black. Okay, so in the first section of the function, we got the data. In the second section of the function, we performed our own data validation. And then also here, probably, if basically we fail the validation here, the joints data are not like 26, also I'm going to return from the function. As you can see here, like we have 26 joints. If it's valid, it's just, we are going to just, let's print a string, say hello. If the data is valid, now we should see hello on the screen. Also, you could change the color or whatever. Let's make it yellow, or the duration of the message that appears, and also other options. But let's see, let's play. I'm not seeing any hello. That means I don't have any data, but let's maybe put on the headset. I'm going to connect it, launch the, okay, I am inside my Quest Link environment. Then I'm gonna hit the preview button. Let's see I don't have any data. So something is wrong because I move my hand in front of the headset. Unfortunately, you can't see it, but yeah, I am moving. Let's see what's going wrong here. So I'm gonna maybe remove this print string and put it somewhere. Ah, okay, I know what is wrong. Let's go back because we never called this function that we just wrote called get join transforms. Inside the basically event blueprint, I'm going to do it inside event tick. Event tick is basically whenever on every frame, whenever every frame of the game is going to draw, we are going to call this function. Of course, you should not always clutter the tick function because it's going to run every frame. And when you have very intensive data processing, you should not put it on tick. But for the purpose of this tutorial, I think we can do it safe. There's not too much processing here. So I'm going to call the get joint transform for the left hand, and then yeah, it's going to call my function and pass in the left hand here as the input, and it's going to return a transform to us. But for now, we want to just compile, save it, and then run it to see if I see the hello. As you can see, yes. I successfully basically called my hello function, got the data, validated it, it's worked. But as soon as I touch, for example, a controller here, as you can see, I'm using the Unreal controller code because, as I said, this VR template comes with some setup for you. For example, they did set up teleporting system and also animated hands using the controllers. If I press the controller button, for example, as you can see, it just plays the animation, and also I could teleport inside the world. But as soon as I leave this for a few seconds on the ground, as you can see, it's somewhere I put it on the table, but yeah, you see it where it is in the real world. Now it is tracking my hand. So we successfully managed to now get the tracking data. As soon as I pick one of these and we touch basically these stuff, the hello messages are disappearing. So it was super easy to get the data and then do the validation. Let's go back inside this function by double clicking it. Now I'm gonna remove this. Now I know my code works. I want to return the actual data. So I'm going to define another variable inside the local variables. Make sure it's inside local variables, because if it's inside variables, it's going to be accessible inside this whole blueprint. So every time you come into function, you are going to add 26 joins every time because it's accessible everywhere. But I want to just keep it local to this function. Outside this function, this variable does not exist. I'm going to call this joint transforms, and here I'm going to define this as type transform and make it an array. As I said, we want to return that data for 26 joints. So now we have this. Basically, if the validation succeed here, perform data validation. Here, what am I gonna do? I'm gonna get the data again from these, and then what am I gonna do with this is going to perform some validation. So here, I'm gonna basically run a for each loop for one of these arrays. It does not matter whether it's the hand key position or hand key rotation, because both of these are going to have the same length. They are 26 joints for each of these, so both of them are 26. We already validated this in here. So I'm going to connect this. Once the data is validated, I'm going to iterate the loop. And what I want to do is to create a new transform based off these data and add my own scale to it. So we have a valid transform for every joint, and then later on we draw the hand. So inside the loop body, what am I gonna do? Here, for the completed, we are going to return, but inside the loop body, what I want to do is basically get a transform, get a ref. Basically, once let's explain this first. For any array, you could, when you do get, you could get a copy of the data, which is going to in memory copies the data. It could be huge. That's why I prefer to work on a ref, which is a reference. It's not going to copy the data. It's going to copy a reference. It's like a pointer to that data, which just returns the address. I don't want to just copy those nodes like every time I want to use them. I just need the reference, and when I want to make the transform, I want to make the actual copy. That's why I use the get ref. Otherwise, there's no difference in terms of performance. The ref is better, but sometimes you want to modify the data. That's why you don't want to modify the original data. You want to get a copy and create a new one and then modify that one. But for now, the ref is enough. Also, I don't like it the way these nodes are arranged. Maybe we double click on this and then we call this rerouting inside Blueprint. You could double click on any of these basically connections, and it's super difficult to select now. Let's do it in here. Okay. As you can see, I can reroute these, so reroute them, and then what this does is going to make the code looks cleaner. So I'm going to do the same thing with this also, because I want to make this look as clean as possible. So also I could select these, basically press the Q button. It's going to keep them in one line like this. And it's very handy in order to organize your Blueprint code. So here, what am I gonna do? I'm gonna get a ref. I'm gonna basically create make transform to create a new transform from this. For every one of these, I'm going to create a new transform and add it inside this basically transform. So this is for that one. Also, let's get a copy of, get a ref of that rotation as well. Get ref. Okay, here. I'm also, as you can see, because the transform accepts the Euler angle, but this one is a quad. The Unreal Engine automatically created the quad conversion to the Euler angle, which is a rotator inside Unreal Engine, and it does the basically conversion automatically. But this is going to only get the first element of the of this array of joint locations or joint rotations. But if I, inside the for loop, if I connect the array index, which is the like a for loop, you have an index, it's going to increment when you iterate over any of those items. So for example, the first time it runs, it's going to be first element, second element, third element, and so on. So I'm going to use this to basically get the first joint, second joint, third joint, and from those, I'm going to create another transform. Also, in Unreal Engine, because the size of the cube I'm going to use, it's 1 meter by 1 meter by 1 meter. I want to reduce this to 1 centimeter. So that's why I'm going to divide this one by 100 and get this number. This is going to be the scale of the joints. So they are going to be 1 centimeter cubes. So this is all we need from this function that we want to return. Now we got it for one basically joint. I'm going to, inside the loop body, basically I'm gonna get the joint transform here. I will get a reference to this local variable we defined. We are going to cache our locations, our transforms here, and I'm gonna call add. which is going to basically, this is an array. I'm going to call add. What we are going to add to it is this transform that we just made. So here it's just going to add it, but it's not going to execute unless I connect this to it. So then here, as you can see, I just basically iterated the loop, and inside that also I want to reroute this. So this looks a bit cleaner, as you can see. Now here I'm gonna select this, and after basically adding that, I'm gonna comment this. Let's change the color, and I'm going to call this, let's say, process create a joint transform from the joint locations and rotation. So let's recap. As you can see, again, here I'm at the beginning of the function. I get the actual data. I do some data validation, and here I will basically, from that data, the thing I want, I'm going to extract it per joint, and I will basically use that locations and rotations to create a new transform. I will add my own scale, which is 1 centimeter. I will add it to this joint transforms in the local section here. And then once that is added, once the loop is complete, make sure you don't want to connect this add, because you are going to return early. Your loop is going to run once, and the first joint that you have, it's just going to return. So I'm going to basically on the completed, when the loop is completed, we iterated like 26 times. I'm going to say return. It says add return node, and I'm going to return the joint data. So that's it. That's all we need from this function. I can compile it. Now let's save it and basically go to the main blueprint here inside the event graph. As you remember, we were going to, inside event tick, we were going to call the joint, get joint transforms. I'm gonna add another print here, and the transform I'm going to receive, I'm going to get the length, and if it shows 26 whenever I move my hands, basically we did everything probably correctly. So let me put on my headset again, and okay, now I get 0 because my controllers are active. As you can see, the hand. Okay, now the controllers are deactivated and I am seeing 26. But whenever I use the let's restart the game. Whenever I use the controllers, I have the joint transform 0. But when I put it aside for a few seconds, you see there, like I have 26 joints. That means I extracted everything the way I wanted. Now I have the data, now I have the transforms. I'm going to draw a hand, but for drawing the hand, we need to add a component inside this blueprint VR hand. That's why I use this add section here. I'm gonna add an instance static mesh. It's just basically a static mesh, which is a cube here. I'm gonna use this drop down here to specify which cube I want. This is already shipped with the engine and also the VR template that we created. There are a bunch of static meshes here, but I'm going to filter on cube, and I'm going to use this SM chamfer cube, which is this blue one. And when I compile it, it also has a material. You could also go to the material editor, change the color or whatever you want to do with it. But I'm very pleased with the current color. So I'm going to save this. Now, we have an instant static mesh. Whenever we get the data for the left or right hand, we want to spawn one of these inside the world at a specific location and the rotation with the scale, which is all this transform is all about. As you can see, for example, if I get a ref of these and I click here, split it, there's a location, there's a rotation, and there's a scale. I'm gonna basically spawn one of these at that location, but I constantly move my hand, and if I basically keep spawning, I'm going to show it to you. The problem is, like, I'm going to just spawn and there will be lots of cube. We soon run out of memory. Not only it just does not look good visually, but also you are going to run out of your memory, and probably the operating system is going to crash your game because it's just using too much memory. But for now, let's, basically we should have a mechanism to clear this instant static meshes. So that's why I'm going to create a function, call it clear hands. What am I gonna do? I'm gonna get an instance of this instance static mesh, and I'm gonna call clear instances, which is going to clear everything for me. So whenever I call this function, it's just going to clear all those instances. For now, we are not going to use it, but yeah, that's the definition of the clear hands function. So also, I'm going to add another function. So I'm going to call it draw hand, because it's not hands, it's draw hand, because we are going to draw one hand, basically the left hand. And as the input, what I want to give to it, I don't care about the hand here, whether it's left or right, but the transforms. Whenever I have the transforms, I pass it to it. I know it's a left hand or a right hand based on the data I have. So here I'm gonna add then another function, parameter, call it joint transforms. So when I come to this function, I already have the joint transforms. And then what am I going to do is going to basically iterate this. I'm going to say for each loop, I'm going to iterate it. So then what happens is I want to spawn an instance of this instance static mesh. So I'm going to say spawn, or maybe add instance or something. Yeah, add instance. It was add instance. So I'm going to add the instance to in the loop body. For every iteration that I'm going to run, I'm gonna add an instance, and the only thing that this one is required is a transform, which has the, as I said, if you break this down, basically split it, it has a location, rotation, and a scale, which is the only thing that we need in order to draw something. Also, one important thing is these are in world space, because if you don't do that, basically it's not going to draw at the desired location. It thinks it's in local space. So we can check that. Let's go back inside the event graph. I'm going to call the draw hand function, and for the draw hand, the transforms I get from the joint transforms, I'm going to pass it to this function. And inside the draw hand, I don't have to validate the length, because this for each loop is going to only run whenever there's data available. So let's go back inside, compile it, and as you can see, I should not be seeing anything here. I don't, and oops, actually I saw something, but it was not at the correct location. Let's take a look. You see at the distance, whenever I move my hand, it's just in the right, like wrong location. So it's just going to process from the local space. But anyway, I'm going to end this. Let's first fix the function. So I'm going to make this world space. It's just going to spawn at the correct location. Now I'm gonna as you can see, I have my hand in front of me, but because we don't clear the instances, it's just really weird. So let's end the simulation, come back here, go to the event graph, and here I'm going to basically disconnect this. Whenever the event tick is called, I'm going to call clear hands. So this is going to clear the instances. Then I'm gonna add a sequence. What is a sequence? Is basically it's just going to run your code in a sequence. The first thing I want to do is call this code as the first series of actions. I'm going to call it for the left hand. Then I will duplicate this. I will select this, press Ctrl D. In older engine versions, I guess in version 4, you could do Ctrl W. But here I'm going to connect this to this one and do the same thing, this time with the right hand. So the sequence is like this. At the begin play, it's going to clear hands, which is going to basically clear all the static meshes that we spawned. And then it runs another sequence, which is first going to get the joint transform for the left hand, and it just does the drawing for the left hand, and then do the same thing with the right hand. We get the transform. We are going to draw it. Let's see it in action. So as you can see, I have my hand. I will make any gesture I want, and basically when I do that, it's just going to replicate my hand inside the virtual reality. Also, you see the shadows on the ground, which means these are basically spawned in the world. Sorry for interruption. It's just because Oculus Quest recognizes some gesture when I move my hand, so that's why it just pops up some menu inside the game, and it was interrupted on the PC. But anyways, cool. Now we have the data. We want to do gesture recognition. We want to, whenever we do a pinch, we want to spawn a particle. And once we do that pinch, we want to basically do something. For example, you want to teleport inside the world, or run a command, or whatever. But here, when I do the pinch, I want to basically spawn a particle. It's super easy to do the pinch detection. We are going to do it, and that will conclude our tutorial. So let's go back inside our code, and in here I'm gonna reopen the blueprint. I'm gonna define another function. I'm gonna call it check gestures. Maybe I want to check for more than one gestures. Anyway, I'm gonna, as input again, get the joint transforms, because that's all I need. And inside this, what am I gonna do? Basically, let's go back here. I'm gonna check. This is my algorithm for detecting a perfect pinch. I just check the thumb finger with the index finger, and then if the distance, I'm going to calculate the distance between these two, like from the tip of the finger to the tip of the finger. I don't care about other joints like distal, intermediate, proximal, metacarpal, whatever. We just care about the tip to the tip of the finger. If the distance, we calculate the distance. For example, we have a threshold. If the threshold is less than 1 centimeter, for example, then that's a pinch. And as you can see, it's going to work, this simple algorithm. So let's go back here. What am I going to do is basically get directly the joint data for those index and thumb tips. That's why I need to right click here, type E hand key point. And here we define a literal enum, which means basically which joint do you want. As you can see, it's just like the picture I showed you. It's just like the index tip or the thumb tip, for example. This is the joint name. This one is the thumb tip, and we need the index, basically index tip. So let's go back here, and I have this one. I'm going to duplicate it using Control D. I'm going to make this one index tip. So I want to get a reference. Let's get a ref out of this, get a ref. And what am I going to do with this basically reference is I'm going to connect this. It's going to be casted because it's an enum. Those who have programming languages like C++ or C know you can cast the enum to integer values. So because it's 26 joins, it contains all those. The data is just going to cast this into an integer, pass it as an index to this get reference. And I will do the same thing here. Get a ref. Let's reroute this as well. And I'm gonna get a reference for index tip. Now, okay, I think that is good. So now I have the transform for the thumb. I have the transform for the index, the tip. And then once I do have that, basically, what am I going to do? I'm going to split this struct, also split this struct. So I have the location, rotation, scale, whatever. Then I'm going to do some vector math, and it's just going to be, I'm going to call it distance. Basically, we pass the distance between the thumb tip and then sum the index. We calculate that. It's just going to return a float. It takes two vectors, which is the location of each of those joints. And once we have that location, we are going to do a check. We say if it's less than the threshold that we have was 1 centimeter, then we detect basically pinch. Want to see it in action? Let's print a string here. Print a string. Also, we need a branch here. That's a if. If the result is true, so I have to basically connect this to this branch here. So I'm gonna select these two, press Q, so they are in one line. Basically, what I do here is just add a comment. I'm gonna say calculate the pinch threshold. Calculate and check maybe, because we also calculate the threshold and detect a pinch. Yeah, because we are also detecting the pinch here. If it's true, I'm gonna say here, instead of hello pinch, detect it. So that's it. That's all we really need for detecting a pinch. What we did is just got the thumb tip, index tip, got their transform, and only used their location. We did some vector math, like calculating the distance between those. And if it's lesser than a certain threshold, for example, 1, we are going to print something, say pinch detected. Okay, let's compile this, save it, and then go back inside our virtual reality to see if we really did detect a pinch. So I'm gonna VR preview this. Yeah, now my hands are here. Take a look at the upper side of the screen, upper left. And then when I do that, it says nothing. Why? Because the mistake that I always make, I believe, it's going back to the event graph. We have to call the function like the pinch detected. And also we need to pass the transforms as well. Let's reroute this, make it nice and clean. So I'm gonna control D this, and after I draw the hand, then I will check the pinch as well. Double click, reroute, double click, reroute. So now it should be running, I believe. So it says pinch detected, but let's see, now it does not say something, but let's see. Yep. Yeah, as you can see, when I do the pinching, it just prints the pinch detected because it's running like every frame, and probably now I'm getting 120 or something frames. That's why it just basically running. So I can also type here stat when you press the tilt button on your what do you call it, keyboard. You could just get a console command, and there I write stat fps, and as you can see now I have 70 something frames, and that's why this function is running a lot. But the thing is, it does detect the pinch and it just works as expected. But I could also check the threshold for you. Basically there's something bad here is going on, which made my computer freeze for a second. Okay, the thing is there were some errors. Why? We made like a rookie mistake. The thing is, if I go to check gestures here, and if I come here, I basically directly access the array, because sometimes that array basically does not contain anything. For example, I say, give me thumb tip, which could be index, for example, 12, but the array length is 0. There's no data because you use the controllers. So what happens here is basically I access invalid memory. In C++, this is going to crash, but in Blueprint, because right now at runtime, it's definitely going to crash, but inside the editor, it has some safety mechanism that is not allowing it to crash. So here, then before I do anything else, I want to basically get the transform, and I want to do a length check on this. So that's why I'm gonna have a branch here. Let's add a branch, and I'm going to connect this to this. And on the branch, I'm going to do the check here. I say if it's greater, or just do the equal. If it only equals 26 joins, then you could basically move forward with the processing. Otherwise, it shouldn't. Validate if we indeed have 26 joins. So I'm going to compile it, and I believe this should be fine. Now let's rerun it again. I'm going to do the pinch. It's detected, as you can see. And when I stop the editor, there should be no errors, which means we did the data validation correctly. Let's make this black as well. So that's the only thing we do. We do some data validation here, and that resolved the issue. Before basically accessing any of those array index, we should verify indeed we have the data. So that's it. And I believe now we do the pinch detection correctly. We wanted to just check the threshold before we spawn our particles. Let's go back to the check gestures here. For example, I say if it's 5 centimeter, let's see. So here I do the pinch, just take a look at the screen. And as you can see, now I have 5 centimeters here. That's why the pinch is getting detected. But if I make it more, for example, like, I don't know, because my other hand is pinching, I should be careful. So let's keep my hand inside the screen so you can see it. As you can see now at 5 centimeters, it's going to detect the pinch, but if I increase it, it's just not gonna do it. Or same here. So I think 5 is too much. Let's keep it back to 1. And that's a perfect pinch for me. So let's go back inside the event graph here. What I want to do inside the check gestures, instead of this print string, I want to basically spawn emitter. Emitters are going to be used inside Unreal Engine to spawn a particle. You could do it attach it to a blueprint or something, or you could do it at a location. I'm going to use the spawn at location here. And what I need to pass to this probably is the scale, location, and rotation, which is the transform. So if we did some calculations here with the transforms, basically for this one is for the sum, the transform for the thumb, the transform for the index tip. I can spawn basically my emitter at any of those locations or rotations between these two, but I want to do it at the space between those fingertips. So at the space between the thumb tip and the basically index tip. So not exactly at the thumb tip or at the index tip, but the space between them. For this, I'm going to use something, a lerp mechanism, something that is called lerp. And I'm going to do it basically between those two transforms. So here for the location, I'm going to say lerp. You see it here, lerp 2 vectors. Okay, let's move this a bit. Maybe it was too much, but anyway. Also for this one, I'm going to connect this one here. We can also make it nicer like this and this. So we do lerp the location, as you can see here. Also, now, also I need to do the same thing with the rotations. So I'm gonna do a lerp between rotators. You could also do it between quads, but what I get here when I break it, it's just rotation. That's why I do a lerp rotation. So I'm gonna lerp between those two rotations as well. So let's reroute this a bit. So that's it. That's all we need. And then basically when I spawn the emitter, I'm going to connect the lerp location. Oh, I forgot something. When you say alpha 0, that means basically it's going to use the location from the thumb, the first one. 1 is going to use the location from the index tip, which is the second parameter. But when you put here like 0.5, that means use half of the location from this, half of the location from this. So it will be the middle point. Also for the rotation as well, I'm going to do a lerp between these. But for the other one, the scale, it doesn't matter. Whichever I use, I'm going to use one of those locations. It does not matter to me which one. So you could get from this or this. Also, in addition to that, you say which particle you want. This VR template comes with some particles as well, because we did add the starter content. So I'm going to choose this explosion, and I forgot to connect the rotation, of course. And then basically make this a bit nicer, maybe. Okay, just I'm fine with this. And then, yeah, it's just going to, we are going to leave the rest as default, activate the system automatically, and destroy the particle. So I'm going to comment this. I say I'm going to comment this, spawn a particle. So let's save it and then run it. Oops, as you can see, we have the nice particles at the fingertips. It's not going to happening for the other one. We successfully detected a pinch, and also now I could paint inside my world whatever I want. And yeah, as you can see, I have this. And maybe you don't want to basically spawn particles every second because it's going to be degrading for the performance. You could have some smoothing mechanism, basically detect if your particle is already playing, you don't want to play it again, or with the sound or something like that. But these are two advanced topics. We're not going to cover those. But for the time being, as you can see, I have a functional hand animation using the OpenXR data. We learned how to do hand tracking in VR in just our introductory tutorial. And also we learned how to do advanced stuff like gesture detection. I hope you've enjoyed this tutorial, and let me know if you want to know any specific topic on the VR development or hand tracking, so I could cover this. And if there's demand for more tutorials, I'm gonna definitely make more tutorials. But don't forget to also subscribe to my channel and support the work I'm doing. Thank you very much. I hope you've enjoyed it. While preparing the video to be uploaded to YouTube, I realized I forgot my promise to show you how to make the code compatible with Unreal Engine 5.5. And this happens. Apologies for that. Sometimes things escape me. And then basically I decided to add this extension to the end of the video. Okay, now we have our project. It's already built for Unreal Engine 5.4. I'm going to close the project, save it. And here, as you can see, I have Unreal Engine 5.5 installed. I don't have to create a new project. I have to just go to desktop. Here, I'm gonna go to the folder that contains my project. I'm gonna make a new copy. I can delete these folders and then make a copy of the rest. I'm gonna make it Unreal Engine 5.5. So that's why I'm going to name it VR Hands 5.5. And then here, the only thing, as I said, you need is config, content, and the VR basically Hands project. I could right click, switch the engine version here. It just appeared on my second monitor, and here choose 5.5. Or alternatively, I could open it inside a text editor here and change this line from 5.4 to 5.5. And that's it. That's what you need to open the project in 5.5. I'm going to open it. Just remember one thing when you do that. As you can see, all the other folders were created once the engine is opening. As I said, you can open previous basically projects that are done with the previous versions of the engine, but as soon as you save the binary assets, for example, like the VR, where was it? It was here, BPVR hands that we created. It's a binary asset. Once you save it in a newer version of the engine, you cannot basically most of the time open it inside the previous versions of the engine, unless of course you do some hex editing or something. That is also possible, but it's really difficult to do. That's why we did first create it in 5.4, and then we want to basically port it to 5.5. But let's see if it just runs right now. I'm gonna go to VR preview. it of course still runs, and I could spawn my particle. Of course, it's building shader, that's why it's a bit slow at the beginning, but now everything looks just the same. But in C++, when you call those functions that we call from Blueprint right now, you will get a deprecation warning. That's why maybe you want to, or in the future you see this video, you want to make it compatible with the newer versions of the engine. So for that, I'm gonna open the blueprint. As you can see, again, Unreal resetted everything. So I go to editor preferences. I'm gonna make this main window because I don't like that to just open in a separate window. Okay, now here, when I press the compile button, also, yeah, it says usage of get motion controller data has been deprecated, replaced with get motion controller state or get hand tracking state. Basically, what they did, they separated the get motion controller data into two different structs. One is get motion controller state, which is specifically for motion controllers. The other one is get hand tracking state, which is for hand tracking stuff. So what am I gonna do? I need to go to the source of the problem here, and it's inside the get join transforms function, which we wrote earlier. Here, what I can just have to change is, instead of this, I'm gonna say get hand tracking state, and I'm going to connect that node to this one, connect this. I use the control button while I hold the control button. Basically, I'm going to drag this so I don't lose it, which other node it was connected to. Of course, so you always could make a new connection, but that would be easier. And then there's a bit of a difference. Like here, for example, it says you want the coordinates, the transforms I'm going to return to you to be in the XR tracking coordinate or Unreal World coordinate. We keep it at that, but the other parameters are just the same thing. But what it returns is going to be a bit different. That's why we need to do some other adjustments. But yeah, basically that's it. They simplified everything, so it's even more easier to use. But yeah, let's remove this. And here I'm gonna, because there's a lot of connections here, I don't want to lose them, so I hold Control key and then connect these to hand locations. You see hand key positions change to hand key locations. And also for the positions, I'm gonna control drag it to here. And that's it. I guess, oh, you only have to just connect this. There's only one more, device visual type. I will talk about that one, but for now, let's delete that. So we were doing, with the previous version, we were doing a check if it was a controller or if it was indeed a hand. Now we don't have to do that anymore because we explicitly ask the engine for the hand tracking data instead of motion controller data. As I said, it's just got even easier to use. So that's why we probably don't need this. So I'm going to directly connect that to this, and this is now redundant. I'm going to remove this, and oops, I'm going to remove just this part, and that should basically remain. So if we did everything correctly, if I'm going to basically press the compile button, everything should be working. Now let's save it and run the game to see if everything works. Well, at least for the left hand it works. For the right hand, I don't have it. Why? I don't know. Probably I can guess I did something wrong here. Yes. I forgot to connect the hand here. I missed this one. So now basically I'm going to get it only for the for both hands, but previously 2 times I was calling the function from the event graph, but always getting it for the left hand. So let's go back. And as you can see, everything works as expected, right? Yeah. So that's it. I hope you've enjoyed it and see you on the next one.